All right, this is example 10, which is from the syllabus. It's an HSC question from 1987, a long time ago. First part says, let OABC be a square on an argand diagram where O is the origin. Points A and C represent the complex numbers Z and IZ respectively. Find the complex number represented by B. Now, the first thing to do is to actually draw the argand diagram. So here we go. Draw the argand diagram. We're going to have real Z, imaginary Z, and we will put point A here, and point C is here. Okay, this is point Z, and this is IZ. All right, and so B, it's not going to be the best drawing. You can see is going to be out here. It's going to be B. It's a square. All right. So the question is asking us to find the complex number represented at B. We need to know properties of a square. All right. So we're going to have a complex number at B represented by that line, which is the diagonal of the square OABC. Now we know also about a square that the diagonal creates an angle of 45 degrees with the side, and we also know if, say, let Z be cis theta, all right, we know then, because of Pythagoras' theorem, if that's modulus of Z is R, then side AB is also R because it's a square, and we know that the length of OB is R times root 2. Okay, just by Pythagoras' theorem. So that means that the complex number at B is going to be a 45 degree, or no, we actually know it's going to be the modulus R root 2 cis theta plus 45. Right, because we know our theta is there, the theta of our number Z, which is represented at A. Okay, so R root 2 times cis theta plus 45 degrees, can we put that in terms of Z, which is R cis theta? Okay, so we can actually do that by separating it out into R cis theta times root 2 cis 45. If we multiply what I've just written, we get back to the line above. Okay, and I've done that because R cis theta is Z, right? And root 2 cis 45, we can draw a little diagram of that. I'll just draw it up here. So 45 degrees and root 2, that's just our one triangle. So that is going to be 1 plus I. So the complex number at B is Z times 1 plus I. All right, moving on to part B. The square is now rotated about the origin through 45 degrees in an anti-clockwise direction to OA-B-C'. Find the complex numbers represented by the points A-B' and C'. So we need to remember that a rotation anti-clockwise by 45 degrees is like multiplying by cis of 45 degrees. All right, so we're going to multiply each of A, B and C by cis 45 degrees. So let's look at A dash first. A dash is therefore Z, which is A times cis 45 degrees. All right, now I know that cis of 45, if that's 45 and that's 1, then this point here, this side length is 1 root 2, this side length is 1 root 2, so cis of 45 is equal to 1 plus I over root 2. So A dash is Z times 1 plus I on root 2. Our b dash is going to be the b from our question above, z plus times 1 plus I times cis of 45 degrees. Now we need to get our b dash in cis form, and we actually had it earlier, which was r root 2 cis of theta plus 45 degrees times cis of 45 degrees. So that is equal to root 2. We need to add the arguments, cis of theta plus 90 degrees. Okay, and we can again separate that out into an r cis theta times a root 2 cis 90. Okay, so we can see that r cis theta is z, and root 2 cis 90 is simply I root 2. So b dash is z times I root 2. All right, let's have a look at c dash now. Our point C was IZ, and we're rotating by 45 degrees anti-clockwise, so it's times cis 45. Now, IZ is simply R cis theta times cis of 90, because that's I, times cis of 45 degrees. Okay? Now, that becomes R cis of theta plus 135 degrees. Okay, now that becomes r cis theta plus cis, not plus, times cis of 135. Okay, and if we look at cis of 135, this is 135 here, this is negative 1, positive 1. So this and that is z times minus 1 plus I over root 2.